Hi everyone, welcome back to Mind Maths with Amna. In this video, we solve the Samuelson Multiplier Accelerator model under rational expectations. We derive the reduced form dynamics of income and investment, explicitly solve expectations, and show how past income affects current outcomes. What's interesting and sometimes surprising is that higher income last period can actually reduce current income and investment. So by the end of this video, you will understand exactly why that happens, both algebraically and economically. This is, however, a graduate level treatment, so I am going to focus on structure and intuition rather than unnecessary algebra. So let's start. I'm going to first put, we have aggregate demand is equals to aggregate supply, and we have the consumption function and the investment function. I'm going to substitute equation 2 and 3 into equation 1. Okay, put equation 2 and equation 3 into equation 1. Okay, we'll get a yt is equals to cyt plus expected value of yt at time period t minus 1. This is the consumption function. Now the investment function, v, which is basically known as the accelerator, the change in actual income plus the expected value of investment at time period t minus 1. Government spending is actually taken as constant, so I'm just going to add a g here, and then we have our demand shock, which is normally distributed with mean 0 and constant variance. Okay, from here we can take all y's to one side, these, yeah. Okay, let's do this. 1 minus c minus v into yt, and then this can be written separately, this can be written separately, this will go separately. Okay, actually yt minus 1 is known, so let's just write it with g. Okay, so we have expected value of current income where expectations are formed at the previous period, and plus expected value of current investment, okay, plus g minus v by t minus 1 plus the demand shock. Okay, this is in fact the structural reduced form of y, because this is actually predetermined, because you've already decided the value that you expect of income in the previous period. So this value is predetermined, therefore it is known. This is also predetermined, determined, misspelled this one, and therefore it is known. Okay, government spending was exogenous. This is a known constant, and this is just a demand shock, and it is also exogenous, while all these are parameters which are known. So basically, if I express yt in terms of all of these, this is technically speaking the structural reduced form of yt. But if you end the solution here, you most probably, even though this is kind of like an acceptable solution, but this is not what this particular question asked. Let me show you the question. Structural reduced form of yt. So why isn't this a perfect answer is because the question specifically asked us to derive the reduced forms of y and I under rational expectations formed at t minus 1 and express them in terms of parameters only. So we can only express in terms of parameters and exogenous variables and lagged variables. So we aren't really allowed to use the expected value of these variables. So hence, in order to get the reduced form, we actually will need to eliminate these two expressions. So we need to figure out a way in which we can remove these two. So we need to figure out a way to remove these. Okay? So remove these two. Therefore, what we need to do is that you need to express expected value of yt and expected value of it in terms of parameters, constants, and exogenous variables. Okay. So what should we do? Let's try to find, let's work on this. Put the expected value, take the expectations of this expression, and let's see what happens. One thing to note is that I'm sure all of you already know that if you take the expected value at t minus 1 of an already expected expectations of yt at time t1, it's basically this doesn't make any sense. You're not going to square it or anything. It's just it's the expected value of yt at time t minus 1. So let's take the expected value. On the left hand side, I'll get the expected value at t minus 1 of yt. All of this remains the same. Okay, and now what we can do is I can take this as common. So I'll have a 1 minus c minus v minus whatever this is called, expected value at t minus 1 of yt. And let's take investment to the other side as well, g minus v. Okay, so let's box this and call this our equation 4. Okay, let's so I need another equation because when you have two unknowns, that you need two equations, right? So let me write this down. When you have two unknowns, then you require two equations. Otherwise, you will get like infinitely many solutions. We need unique solutions. You need two equations in order to get unique solution. Okay, so what is going to be the next equation? What we can do is we can work around equation 3. Let's write it down first. We know from equation 3, it talks about how current investment changes. It depends on the change in output, plus it depends on the expected value of current investment, and these expectations are formed in the previous period. Okay, if I take the expected value at previous time period of this whole expression, what am I going to get? I'll get expected value at time t minus 1 of vt. Expected value at t minus 1 of yt minus 1 is yt minus 1. Okay, so this remains the same, yt minus 1, plus this remains the same because the expectations were already at t minus 1. We can take this as common, I need the unknown things on my left hand on one side, so let's just make these two the subject. Okay, so we will get v expected value of yt plus this minus a 1 expected value of it, and this will actually go on the other side, so it'll become a v yt minus 1. Remember, these parameters are usually less than a 1, so it'll be better if we write this as follows. It's conventionally better if I write this as a 1 minus this. Okay, so this seems better now, and I'll multiply by, yeah, this makes more sense. So yeah, so let's highlight this as equation 5. Okay, so we have two equations. This is my first, and this is my second one. So we can now write this in a matrix form. So 1 minus c minus v, all the parameters here, minus v minus this, 1 minus this. Okay, now are my unknown variables. Okay, expected value of investment, and now the column vector which has these two knowns in them. Okay, so now we have a ax is equals to b system where we can solve it by either finding the inverse of matrix A and multiplying it by b, or we could use Gaussian elimination, or we could use the Cramer's rule. Let's just use the Cramer's rule. Determinant of the matrix A, usually written as this, is going to be, let's just move on to the next page. Oops, I wanted to cut this. Okay, we want the determinant of this, and it's going to be as follows: 1 minus c minus v minus multiply by 1 minus this and minus into v. Okay, this expression, this is the determinant. And what about the expected value at time t minus 1 of yt? It's going to be, we're going to take the, replace the first column with the column b, and the second column remains the same. We take the determinant and we divide it through by the determinant of the matrix A. We'll get a g minus v into a 1 minus this, and this is going to be a negative v, okay, over the determinant. Okay, we'll have a g minus psi g minus v yt minus 1 plus a v, this yt minus 1. Oh, this thankfully cancels out, so which gives us a tidier version of, okay, this cancels out, so we are left with 1 minus this parameter into g over the determinant minus v over the determinant yt minus 1. So therefore the expected value of current income is some constant a naught plus a1, that's actually minus a1 yt minus 1, where actually we should mention what a naught and a1 are. So where a naught is equals to this, and And don't forget ever to mention what, if you take any, if you're assuming any constants, introducing new constants for simplicity, because this looks a bit untidy and I want to make the algebra as easy as possible. So if I'm introducing a new parameter, I need to state what it equals. Okay, now we can either use the Kramer's rule again to find the expected value of investment, or we could actually even just put it in equation 5. Like, I can put the value that I've already found for expected value, because I am technically solving these two equations simultaneously. So if I've already found the value of expected level of income, I can substitute it in either of these to find expected value of investment. So because converting it into matrix form is solving two equations simultaneously, right? So instead of doing the Kramer's rule, let's just put what we found in equation 5. So let me write this down just in case somebody didn't understand what I said. Instead of using the Kramer's rule again, we can put the value of expected income into equation 5, where equation 5 was this. Okay, so this is going to be the expected value of current investment. I'm just making this into the subject. It's going to be a V into expected value of current income minus past income. So because there was a V in common and I had taken this on the right side, yeah. So I get an expected investment. Oh, actually this had a coefficient next to it as well, so it's going to be divided through by 1 minus this. Okay, so V over 1 minus that symbol there. Now I can substitute the value of expected income. So this was a A0 minus A1 YT minus 1 minus YT minus 1. Okay, so we get V over 1 minus this. The value of A0 was a 1 minus the symbol G over, I think this was it. And if I take minus as common, I'll get an alpha 1 plus a 1 into a YT minus 1, where alpha 1 was V over the determinant. So V over the determinant. Okay, if we open this up, I'll get V over the determinant into G, okay, minus V over 1 minus this into V plus the determinant over the determinant into YT minus 1. So what we can do is we can just call this a constant B0 and call this minus 1 beta 1 into YT minus 1, right? Again, we're doing this to for simplicity because we don't want messy algebra. So just state that B0 is actually V over the determinant into a G, and B1 is this. Okay, so when I introduce new variables, new parameters, I have to mention what they're equals to. Okay, so now remember now we have expressed the expected value of these variables in terms of all parameters and exogenous variables. So going back to finding the actual reduced form, where was the structural reduced form? This was it. And now we've found out what we were looking for. Just need to substitute. So this was the structural reduced form of output, and we just found out that the expected value of output is a naught minus a1 yt minus 1, and we found out that the expected value of investment is b naught minus b1 yt minus 1. So we'll just substitute this both these things in. So we'll get a yt is equals to a 1 over a 1 minus c minus v into so I'm multiplying this by this. Okay, a naught minus this a1 yt minus 1 plus psi b naught minus psi b1 yt minus 1 plus, oops, this is quite lengthy despite the fact that I've tried to reduce the algebra. Okay, there's still the productivity. No, this was the demand shock. Okay, so now I can keep all the yt minus 1 variables together and the constants together. Yeah, and then that'll be my final answer. So I'll get, let me start putting all these parameters together. Okay, so this is the constant, okay, minus 1 over 1 minus c minus v into, we'll get, okay, this was the first expression, second and third, okay, plus this into b1 plus v, yeah, into yt minus 1, and then we have the error term. So we have the error term also being divided by this constant. Okay, so yt can be written as gamma naught, which is a constant, minus gamma 1 into yt minus 1 plus some gamma 2 into the demand shock, where y naught is equals to this. Again, because I want to reduce the amount of symbols that I'm using. So whatever I'm taking for simplicity, I have to mention that. And this one actually easy one. 1 over 1 minus c minus a v. We're almost done. The structural reduced form of investment. Okay, let's search for that. It was right here somewhere. Yeah, here it is. Okay. The structural reduced form of investment was this. Structural reduced form of IT form, FORM. And the thing that was giving me a problem was the expectation sign. So I want to remove that, and actually this as well. I'm just going to substitute my answer from above. So this expression will go right here. Okay, so let's do that. I have a v into gamma naught minus gamma 1 yt minus 1 plus gamma 2 et minus yt minus 1 plus this parameter, and we had taken we had found out the expected value of investment as being equals to this. Okay, now I'm just going to put the constants aside, and all the coefficients of yt minus 1 together. Okay, so we'll get a v gamma naught plus this into b naught, okay, minus we have a v gamma 1 plus 1 plus this into b1 into yt minus 1 plus v gamma 2 et. Okay, so therefore the reduced form can be written as x naught minus x1 yt minus 1 plus x2 et. So in this scenario, this is the reduced form of it completely in terms of constants and exogenous variables, and this was the reduced form required of income. We should also in this part mention what x naught is. It's this. What x1 is, it's this, and x2 is, which is just v gamma naught. Okay, so we are finally done with the question. I'll just give a recap. The key takeaway is that in a multiplier accelerator model with rational expectations, investment responds to changes, not levels, and expectations amplify that effect. Okay, so a boom today creates the conditions for a slowdown tomorrow, which is exactly how these models generate cyclical dynamics. If you're comfortable with this derivation, you're well prepared to move on to stability analysis, impulse responses, and DSGE implementations. Okay, remember that whenever the past level of realized income is high, then it's going to lead to a fall in current investment as well as a fall in current income. When you plug in this model on Dynair, remember that the expected value of yt at the previous time period is in Dynair, expectations are just implicit. Okay, so just write this as y in your in the on the software. There's actually another option as well. Where was it? I think I found it for my students. Let me search their group. Yeah, I was right here somewhere. I'll write it down. So on Dynair and MATLAB, whenever you want to write yt on Dynair, the syntax is y. Okay, whenever you want to write yt plus 1, it's going to be y brackets plus 1. Whenever it's yt minus 1, it's y minus 1. The expected value of future income is just the future income itself, okay, because expectations are implied. Similarly, the expected value at the previous time period of yt is just going to be written as yt itself. Okay, but there's also another way of writing this. Let me just write it in red. You can also use expectation minus 1 y. So this command also works. So it means like you can also use this over here as well. So it's going to be expectation formed at this time period of future, so most probably it's going to be a +1. I'm not really sure about this one, but you can try it. I'm sure about this one because the student already tried it and it worked. Okay, so this is enough for this class. I hope this lesson was beneficial, and if there's any confusions, you can ask me in the comments, and have a nice day. I'll see you in the next one. Take care.